Hello everyone. In this video, I'm going to compare two different embedded devices, FPGAs and microcontrollers. First of all, what is an FPGA? The term FPGA is an abbreviation for Field Programmable Gate Array. FPGAs are semiconductor devices that consist of a matrix of configurable logic blocks or CLBs connected via programmable interconnects. This means that the end user can reprogram an FPGA at any time. FPGAs are used almost everywhere, like fighter jets, commercial airplanes, robots, defense systems, missiles, etc. Now, what is a microcontroller? A microcontroller is a small computer on a single integrated circuit that contains a processor core, memory, programmable input-output peripherals, timers, counters, etc. Most microcontrollers have a computing width of 4, 8, 16 or 32 bits. Some examples of microcontrollers include the Atmega series, the ESP series as well as the PIC series of microcontrollers. The main advantage of an FPGA is that it can process multiple instructions parallelly while a microcontroller processes instructions sequentially. This, along with the presence of millions of configurable logic blocks within an FPGA, allows it to swiftly handle large amounts of data, resulting in rapid output generation. This capability proves invaluable in applications such as fighter jets, where FPGAs are tasked with processing extensive information. Another advantage is that an FPGA can be configured to do anything, while the configurability of a microcontroller is on a superficial level. Now, I will explain each of the differences between FPGAs and microcontrollers in detail. Processing power. Processing power refers to the chip's ability to receive an input, process and manipulate it, and provide a desirable output. With an increase in processing power, a larger amount of data can be processed at a higher speed. The processing power of a chip depends on a lot of factors, such as the amount of area on the chip dedicated to the CPU, the architecture of the chip, its clock speed, etc. As said before, a microcontroller contains not only the CPU but also some memory, I/O peripherals, clocks, timers, etc. All these need to be put on a single die, which means that the area dedicated to the CPU must be ready. This hugely affects the processing power of a microcontroller. An FPGA, on the other hand, relies on external memory, clocks, timers, and I/O peripherals. This means that all the area on an FPGA can be dedicated to processing the received input. It greatly increases the FPGA's efficiency and speed. This is also why FPGAs are used in applications where more processing power and a higher speed is required, like in missile defense systems and fighter jets. Memory. Memory is used to store some data. It can be of two types: volatile and permanent. Data stored in the volatile memory is lost when the chip loses power. Permanent memory retains the data even when there is a power loss. A microcontroller usually includes both types of memory. This allows it to store the program to be run and also the input and output. However, an FPGA only has volatile memory. When it loses power, all the data is erased. This means that it cannot store the program to be run either. To do this, it needs some external memory chip or even an external microcontroller. This greatly affects an FPGA's portability, which I will discuss in detail in the next section. But an advantage of an FPGA is that it can have unlimited volatile memory, unlike microcontrollers which have a fixed amount. This is thanks to the fact that an FPGA contains a large number of configurable logic blocks which can be programmed to imitate anything, including memory. An FPGA can even emulate a microcontroller using code. Architecture. Microcontrollers have a fixed architecture which is set during manufacturing. Reduced instruction set computing or RISC, complex instruction set computing or CISC, and ARM are some examples of microcontroller architecture. The architecture of a microcontroller cannot be changed by the user. An FPGA is just a huge matrix of configurable logic blocks or CLBs which are connected via programmable interconnects. They can be configured by the end user using a hardware description language or HDL such as Verilog or VHDL. This means that an FPGA can be programmed to do almost anything from a simple logic gate to a complex graphics processing unit. On the other hand, a microcontroller can also be programmed in low-level languages like C, Rust or Python. They are easier to program but have many limits such as the available memory and processing power. An FPGA can be programmed so that a portion of the chip acts as memory while some other portion acts as the CPU. This makes it so that there are lesser constraints on how memory or CPU is available. Portability. Portability is a very important factor when choosing between FPGAs and microcontrollers. As said before, a microcontroller is self-dependent, meaning it doesn't need much external components to work. On the other hand, an FPGA depends heavily on external components like memory, clocks, timers, I/O peripherals, etc. Most of the time, common use FPGAs come in boards which contain all the different external components. Usually, there are specific ICs for each function, but in some boards, another microcontroller might be used for the same purpose. This is one of the reasons FPGAs are not used for small projects or projects which have a small form factor. Fitting all these components can be tedious and inefficient. In these cases, a microcontroller is more suited since they have a very small form factor and also a very low power footprint. In other cases where high processing power is required and size doesn't matter, an FPGA will outperform any microcontroller. This is why FPGAs are used in robots, fighter jets, missiles, self-driving cars, etc. Use cases. Use cases depend on all the factors we have discussed previously. Both FPGAs and microcontrollers have their own pros and cons. FPGAs offer high processing power, complete configurability, and flexibility while being easily programmable. This is the reason why FPGAs are used in applications like fighter jets, commercial airplanes, robots, self-driving cars, etc. Microcontrollers are compact, self-dependent, and portable. They are also very easily programmable while still being relatively powerful. That's why they are used in small-scale applications like in home appliances, consumer electronics, medical equipments, etc. These are the main differences between FPGAs and microcontrollers. That's all for this video. Thanks for watching.